Hello scientific brilliant people, how are you today? So today I'm going to discuss about the method to find the volume of the irregular shaped object like a stone over here. So for that there are two methods. The first method is water displacement method, in which you require a measuring cylinder or a beaker, but they should have proper graduations on it. And the another method is Eureka can method, and in this video I would be broadly talking about the advantage of the Eureka can method over the traditional water displacement method. And this video lecture is for grade 6 to grade 12 students, and there are some concepts of Archimedes principle as well. So I would be trying to explain you all those things in a very easier manner. So here I have already filled this water in this beaker till 150 ml, and this Eureka can is made up of copper. It's a very light can, and as you can see a nozzle over here, so I cannot fill water more than this level because the excess water will flow out from here, and this is almost, I have already filled this completely. So if I try to pour more water, the excess water will flow out from here. There is no water inside this one, and now what am I going to do is I'm going to immerse this stone over here. So we know that if I immerse the stone over here, the water level will rise. I know what is the initial volume. After immersing the stone, I will record the final volume. The difference in both the volume, or the amount of water level increased, the volume of water increased, will be the volume of the stone. The same thing I would be repeating over here. I would be immersing the stone inside this one, and the water will flow out. Here also the volume of the water will be recorded, and the increase in the volume of the water, or the water which displaces out, that volume will be the volume of the stone. Both of the method are same, but this has got one additional advantage. We can calculate the buoyant force or the upthrust exerted by the water on the stone here, not over here, right? So let me start the experiment, and I would like to also apologize to my viewers that I don't have proper instruments to measure the volume very perfectly, because here the recordings, I mean here the graduations are from 50, 100, 150, 200. That means the water level could be either between 150 to 200, anywhere in between, and I will have to move by my instincts to get the answer. So I'm sorry for that, but I would like to be more precise as I could, right? So excuse me if I make any mistakes. So here I start my experiment, and I'm going to immerse the stone, and the initial volume is 150 ml. So the initial volume of water was 150 ml. Now I'm seeing this as approximately, it is slightly less than the middle part. So if it is 150, then this is 200, then the middle part would be 175. It is slightly less than that. So I'm going to write the final volume as 172 ml, and the difference in the volume, that is V2 minus V1, is the water displaced, that is 22 ml. And this itself is the volume of the stone, people. So volume of the stone by water displacement method is 22 ml. This is not very accurate, but my purpose is to just show the experiment. And now what am I going to do, people? I am going to immerse the stone in the Eureka can, and you will see that the excess water, or the water which will be displaced out, it will be collected in the small beaker. So here I start. Let the water get collected over here. Here also I can see slightly above 20. So the volume could be approximately volume of water displaced is again approximately 23 ml. There is slight difference in the reading because the graduations are not over here, so I am moving by my instincts. Now as you can see that we have learned how to find the volume. Now we might have a question that this method is very easy compared to this method, but here when you immerse a stone in a liquid, the liquid is going to exert the buoyant force in the upward direction. Now that buoyant force, as per Archimedes' principle, is the weight of the water collected. So that means, or the weight of the water displaced out, this water which is displaced out, its weight is equal to the buoyant force. So what will I do is, first of all I am going to find the mass of this empty beaker, then I am going to immerse the stone, water displaces out. Now the mass of the complete beaker with water is to be found out, and then I am going to subtract the mass of the beaker from this mass, so I am going to get the mass of only water displaced out, and then I am going to multiply it by acceleration due to gravity. So I will find the weight of the water displaced, and this weight of the water displaced will be the buoyant force acting on the stone by the liquid in the upward direction. So here we have an advantage of obtaining buoyant force or the upthrust acting on the stone by the water. So hopefully guys, you have understood the explanation. If you have any doubts, please do comment in the comment section. Kindly leave a good comment if you have liked my explanation. Thank you for watching the video.